morning, everybody. We are team number 3. We are the eco-friendly shallow drop boat team. The team members are David Nair, Jose Arau, myself, Sebastian Lopez, and Domingo Malave. He couldn't be here today. Project advisor is Dr. Claudius Carnegie. We'd like to thank our sponsor and support, Mr. Norman Werman. He's the president of Onyx on the Bay Condominium. And also Ralph Brown, founder and owner of Dream Boats. Mr. Werman, he approached us with a project. He wanted to build a solar boat that carries around 50 people from Biscayne Bay to a small island. Like I say, he wanted to be this boat to be almost powered by solar energy. We have some constraints and rules and regulations. The boat has to be shallow draft, 1 foot depth below water, and like I say, it has to be an eco-friendly boat. Now, Jose is going to talk about design.
Well, basically, we have some design alternative. Basically, this is based on Senior Design 1. We have 3 different designs. The first one is the V-shaped hull. The second one is the round bottom hull. And the third one is the pontoon hull boat. Basically, the V-shaped hull is not good for our purposes because of stability. And it's not good to ride like in rough water. The round bottom hull is not good either because of the form of the shape. As you can see, if we get that shape, we're not going to be able to meet our goal, that is 1 foot of drag. And then initially we start like thinking about the pontoon hull boat because it has a great buoyancy capability. Also, it's really stable, and it's stable in calm waters, and also it's really easy to build. But the problem with that, after consulting the manufacturing boat, is that here that's used for lakes. And here in Florida, it's not good because of the ocean, and sometimes to cut like wave is not good. So that's why we decided to go with the catamaran hull design. As you can see, this is the final design for the hull. It's a catamaran hull. Basically, it has 2 sponsons. Each sponson has a square shape, which is 30 inches width and 20 feet long. Basically, as you can see, these are the sponsons, and that's like a tunnel that it forms. And that's another good thing about that design is, as you can see at the end of the edge, the end of the sponsor, it ends like or it joins into a single point, and it's not like just like a flat ending, which is make the hull be able to ride easy in the water. So it will cut through the water and it use less energy. In addition to that, in order to meet or to ride in shallow waters, basically this boat, what it does is that it has the ground effect. What is ground effect is that it makes sure, we try to put water and air inside the tunnel as much as possible, and that's going to create like a pressure, and the pressure is going to try to go down to the floor, and then the floor is going to throw the pressure up, and it's going to leave the boat. That's how we're getting like to ride in shallow waters. As you can see, here we did like 2 different analysis. We did like for the velocity that gave us like around 5 knots per hour for the hull, and then here is what I was talking about the ground effect. As you can see, this is the pressure where it's going to push down, and then once that hit the floor, it's going to push up, and it's going to leave the boat, and it's going to be able to run in shallow water. Then for the manufacturing, actually the boat is going to be manufactured by Mr. Ralph Brown. And some of the material selection that the team did the research about it is like wood, fiberglass, and aluminum. Basically, the wood is going to be used to construct the mold of the boat, and the fiberglass is to apply to the mold and then get the hull. And then basically, because it's going to be a solar boat, we're going to have some canopy on top. So basically, all the structure is going to be made of aluminum 6061 because of its characteristics. As you can see, here is a sample of the canopy. That's the canopy, so we have to add some rails, and then on top of that, we put the solar panels. So we need to have some air that is going to flow through there, so it doesn't overheat. And this is some example of the chop of Mr. Brown, and something similar to this is going to be the final product. The final product. The weight distribution. Basically, after several meetings with the client, And the last meeting with the mold manufacturer, we decided to go with this layout. Basically, the boat is going to be 26 feet long and 8.5 feet wide. As you can see, it's going to carry 15 people. We're going to fit 5 in the back and 4 at each side. So in that way, we can distribute the weight around the boat, and it's going to be safe. In addition to that, we're going to add like polystyrene foam at the edge of the deck, and that's going to give more like buoyancy to the boat. And in the worst case scenario, the boat can be cut into pieces and it's not going to sink. I mean, everything's going to float. In addition to that, we have some compartments over there for people who want to carry some stuff. They can put the stuff in the back of the boat. As you can see, we have a total weight for the boat of 6,904 pounds, and the water displacement by that boat is going to be 8,263 pounds. Basically, that gives us a factor of safety of 1.3 to run in shallow water. Well, this is the final design. As you can see, we have the canopies on the top. We're planning to use like 6 members to support the roof and some railings in the front in order for safety, because that boat is going to ride like all kind of people, even children, so they can be safe inside the boat. Now, David is going to explain the power of the construction.
Good morning. As was said earlier, the boat is going to be run on solar energy, and so that being said, we're using a PV system with battery storage. Here we see a basic layout of how that would work. There's the solar panels, which the energy from the solar panels would go through the charge controller, which regulates the amount of energy that goes back and forth between the battery and the motor, or the DC load in this case. And this is the basic setup. Next slide, please. For the solar panels, we're using Suniva Op 265 series. Each panel has 265 watts, and there's 60 cells altogether. It's a monocrystalline cells with 19% efficiency, which is fairly high for solar panels these days. The monocrystalline cells use pure silicon, which has a low band gap energy, so that makes it very good for use as solar energy in the solar panels. It's marine grade aluminum frame with hard anodized coating. There's also tempered glass, which can protect it for up to loads of 5,000 pascals, which down here in hurricanes, it's certainly good to have very sturdy panels. There's a 25-year warranty, performance warranty, delivering 80% power at standard testing conditions, which over time the battery will deplete itself, so it's warranting up to the 80% of that power. And here is just a diagram of the IV curve, the current versus voltage curve, and the different powers that you can get. These are the power curves, so the powers you can get based on the amperage and the voltage that is coming out. For the batteries, we're using 2 banks of 4 batteries each. You'll see in a moment that we're using 2 motors. Each motor is 48 volts. So therefore, we have 1 bank of batteries for each motor. So there's 12-volt batteries times 4 batteries. That's 48 volts altogether. The batteries are deep cycle marine grade. They're a thick plate design with low internal resistance, so that increases the life cycle. They also have a high density paste on the inside, which is the electrolyte that helps get the chemical reaction going. And shows on the graph also, but there's a life cycle of 1200 with a 50% depth of charge. And as you can see, the lower the depth of charge up to 50%, you get higher number of cycles. And here is the charge controller. We're using a Flex Max 60. The charge controller, like I said before, regulates the amount of energy that goes back and forth between the battery and the DC load. What's great about the charge controller is that it increases the PV array up to 30%. It also uses advanced continuous maximum power point technology, which from the IV curve from before, it follows and tracks that curve to where there's the peak current and the peak voltage, so that's where you're getting your maximum power, and it tracks it the entire time, so that way you're always getting your maximum power out. And it logs performance data for 128 days, and it's warranted for 5 years. And the motors we're using are 2 Torpedo Cruise 4.0 R motors. They're 48 volts electric motors with 4,000 watts of input power, and 2,240 watts of propulsive power. They're high efficiency, 56% efficiency, which is very high. They use plastic propellers, which that helps prevent cavitation at the tips of the blades. And it also comes with an integrated display showing the battery usage and GPS-based speed and the remaining range. Next slide, please.
Okay, like David said, we're going to use 2 motors. We're going to use 8 batteries. And you can see here, this is the cost analysis of the project. All the components needed to move this boat is going to be around $17,000. The hull for the vessel is going to cost $33,000. So adding all this up, the project is going to come around $50,000. And you can see in the table downstairs, we show different boats with the kind of similar dimensions. And you can see one is gasoline, one's electric, and as the Mr. Worman wanted, he wanted a solar and electric boat. Now,
I'm going to talk a little bit about Global Learning Initiative. Global learning examines the technologies developed by humans and the impact on culture, politics, economy. It's broken down into 3 different categories. There's global awareness, global perspective, and global engagement. Next slide. The global awareness, it looks at the different types of technologies that are similar out there. For boats, there are other solar boats in world, in country. But what makes it unique is that it is solar. It is something that's not as commonly used as gasoline or diesel engines. But it's not surprising that solar power is a big thing, seeing that more energy in 1 hour comes from the sun than is used by everyone in the world in 1 year. So even though there's a lot of potential for the use of solar power and solar energy, there's still a lot of opposition. There's lawsuits over rights to land and activists who don't want to hurt land, protect land. And then, of course, there's those other obstacles, political obstacles that need to be faced. And for a global perspective, cost of solar panels is notoriously high. There have been issues of ways of trying to solve that. President Obama did a tax credit. 41 states offer loan programs that would help subsidize the use of solar power. In Germany, where they use 14% of its electricity coming from renewables, they finance solar power subsidies by putting surcharges on the electric bills. Next slide, please. And global engagement is about finding solutions to problems, issues, and the willingness to come together and find what limitations there might be and how to go about that. In the solar market, to really be truly competitive, we have to find ways in order to deliver the power and the efficiency that's equal to the other technologies that are out there.
okay, this is our project timeline. As you can see, it's like we met every task that we had, we accomplished it. As you can see, I'm going to tell some of them, the times that we met with the client, all the research that we did, all the projects, and we haven't done what is the final, the boat manufacturer and the solar installation. That's going to be done after we finish this project, this presentation. And the next slide is going to show the division of labor. We divided everything equally. And this is a video that we have from the manufacturing boat. This boat rides on 1 inch below water. And that's Mr. Ruff. Yeah.
so
I'll
you can't
put
hear
it-
what he's saying.
Better video next.
But that is the boat manufacturer.
You guys have any questions?
Yeah. Was there